Hey everyone, welcome back to the TILTEDU channel. So in the previous videos, we covered the coding inside of Unity. Now in today's video, we'll be jumping into the player mechanics and setting up our player controller as well as implementing the jump function. So without further ado, let's jump right in. So if you remember, a few videos back, we set up our very own level inside of Unity using the SSFP model inside of Blender. Now today we are going to leverage this level and set up our very own player controller. Now instead of using the mannequin that we downloaded earlier, we'll be using a default cube. And don't worry, we'll get to the mannequin part when we are setting up the animation as well as the blend tree for it. But for today's reference, we'll be using this cube as our player, and we'll be setting up a script that will enable us to jump from platform to platform and use our WASD keys to move around. Now, before we get into the coding part of this session, there are a few components that I need to add to our player component so that we can access it inside of our script. Now, one of the major components that I need to add is the collider. Now, since we already are using a default cube that is inside of Unity, it comes pre-built with a default box collider. And for our use case, that is more than enough. Now, another component that we need is the rigid body component. This component will allow us to calculate all the physics related queries, as well as it allows us to have natural gravity inside of the scene. So if I were to place the cube over here and play the scene, you can actually see we are getting the actual feel of the gravity because it's a physics object right now. And we can access this component inside of our script when we get to that part. So I'm just gonna put my cube back, and also make sure you've added some sort of collider onto your platforms. So I'm gonna add mesh colliders to my platforms as well. And be careful if you're adding multiple mesh colliders, they can be a little bit taxing on the computer itself. So it is better, or it is preferred to use box colliders or other simple shape colliders than mesh colliders. So since I'm just showing you as an example, I'm adding mesh collider. So we have set up our level. Now let's get into the scripting part. So to create our very own script, all you need to do is right click on the project window, go into create and C# script. And I'm going to call this player controller. And you can just double click it to open inside of Visual Studio. So before we get into adding our inputs and our logic, there are a few variables that we need to initialize at the beginning of our script. First, I'll be typing in public because I want to access this value inside of the inspector. So we have created a public float value that will allow us to control the movement speed of the player. Now, if I were to save the script right here and wait for it to load, go into our cube, drag this on, you can actually see, since we made it as public, this value right here is accessible through our inspector, and I can just adjust it to whatever value I want. The next one is the jump force. Now, I'll explain why I'm creating these variables when I get to them. Basically, it is to calculate the amount of force that should be inputted while pressing the jump button or the space bar in this instance. Now onto the final component that we need to initialize is the rigid body itself. We need to have a reference of the rigid body component that we added onto our player. To reference that, you can just type in rigid body. So whenever we need to access our rigid body component and its values. Now, what is something that we need at the very start of the game? When you think about it, the first thing we need is to access the rigid body component. Without it, our cube will be standing still in midair, because the physics won't act or work properly. So let's put a reference to that rigid body. I'm going to call in player rigi, and I'm going to get the rigid body component. And to get a specific component, you can just type in get component. And in this instance, it's the rigid body component. Now, if you remember, in the previous videos, we set up a basic player controller using the input system. If you want to explore more about the input system, you can actually go into edit, project settings, and go into the input manager. There are a bunch pre-made inputs by Unity itself. You can actually edit them if you want, or you can use the default input system. I'm gonna keep it simple and use the default input system. Now let's define our horizontal and vertical input systems. Float, just like what we did previous videos. And for the first one, I'm gonna get the horizontal and make sure you spell these correctly. And for the vertical, you're gonna do the same. I'm gonna spell vertical. And I'm gonna save the script and see if that is working. Okay, we are getting the rigid body component because the cube fell and landed on the platform. Now let's see. Now if you press, you can see actually we are not able to move because we just received the input. We didn't define what the input should do. Now let's define our input. For that, let's get out of play mode, go back into our script, and now we need to initialize a vector3 component so that it allows us to control the positional data of our cube. So let's call our vector3 as movement, and let's define the parameters for that 3, that is the xyz axis. And we have already initialized our horizontal and vertical, so we'll just reference it here. Horizontal, since we are not using the y-axis, we can just give it as 0 f, and the next is vertical. And what we're going to do is multiply this vector with our movement speed to get that incremental movement. So multiply with movement speed, transform dot translate, and we want it to be affected by the world space or the world space location. So for that, I'll just call it movement, comma, space dot world, and close off this whole statement. Since we are writing this code inside the update function, this will be executed every single frame, and we don't want that. So we'll be using the time.delta time feature, or the function that was taught in the previous video, right over here. So let's just add that. Move speed, multiply time dot delta. So that should work right now. Make sure you save your code. And if you go back into our scene, the inspector, you can see we have 2 float values that need to be assigned. I'm going to give this around 5, and I'm going to skip the jump power because we haven't added the jump feature. Now let's see if we can move around our scene. And you can see we are able to move around, and the cube has fallen because it right now has rigid body physics as well. So we have set up the basic movement. Now let's move on to the jump functionality. Now to add the jump functionality, we are using the spacebar button for now. And when we are getting into the UI part, we'll be replacing that button with a UI component button that you can access from your mobile phones. For this example right now, we'll be using the spacebar button as our jump button. So we need to get the input of the jump button. For that, we'll be using an if statement. So I'll just go in and type in if input dot. Instead of get access, we'll be using the get key down. So whenever that key is pressed down, we'll receive the input, and set up brackets key code dot space, and give that. Okay, so we have mentioned or referenced our input. Now we need a few conditions. We need to access the y-axis of the player component, so it allows us to jump up and down. So let's reference that by creating a new vector3 and calling it jump up, and this vector3 will be equal to vector3 dot up. So basically, when you're writing vector3 dot up, it will just add a numeric value to the y-axis. So instead of writing it as different axis, I'll just use the shorthand version of this. I'll type in up, and I'll multiply this with the jump force that we initialized earlier on. If you remember, not the jump force, the jump power. So I'll just reference the jump power as well and close off the whole thing. Now let's create a conditional statement calling it if jump power that we initialized at the beginning greater than 0. We want the jump up to access the current forward location of the object, so that it is always jumping towards the front and not accidentally jumping towards the side or the other sides, because usually in games we are facing towards the front, and we also want the character to jump towards the front. Jump up is plus transform dot forward, and we need a new value here to multiply with. So what I'll do, create a new public float, is public float jump forward, and we'll just reference that over here. And finally, we need to apply this velocity or this jump motion to our rigid body. So to do that, we can just reference our rigid body, that is vg dot velocity is equal to jump up, and we can just make sure you save your script. And if you come back, you can see there are a few more values we can add. So I'm just going to give this 2 and this maybe 2 as well. If I press play, and you can see I'm able to jump, and I instantly fell off the map, but that's not a problem. So we're just going to scale this platform up so that we have more room to jump around. And I'm just going to press play, and you can see I'm able to move, and I'm able to jump in the forward direction, that is the z-axis. Hey everyone, so that was just a brief on the player mechanics and how you can handle the player input, as well as a new functionality, that is the jump function. Now in the upcoming sessions, we'll refine all these functionalities, add them into their private voids, as well as create multiple scripts to include other properties as well. So make sure you like this video and share it with your friends who are interested in game development or 3D art creation. Also, make sure you subscribe to get notified when we post a new video. Until then,